Imagine this. Somewhere in the vastness of space, an asteroid the size of a city is barreling toward Earth. Scientists scramble, alarms blare, and news anchors try to remain calm as they explain. We may have days before impact, but then humanity unveils its most ambitious project yet. A magnet. Not just any magnet. A planet-sized magnet, capable of reaching into space and yanking that asteroid away before it turns our cities into oversized craters. Sounds amazing, right? Just one problem. Magnets don't quite work like that. Before we get into why this plan might not be our best bet for asteroid defense, let's take a step back and appreciate just how insane a planet-sized magnet would be. First off, Earth itself is already a giant magnet. Well, sort of. Deep below our feet, the planet's core is a swirling, churning mass of molten iron and nickel, generating Earth's magnetic field. This invisible force is the reason compasses work, why birds can migrate, and why the sun's solar wind doesn't strip away our atmosphere like a cosmic bully. But this natural magnetic field is weak, really weak. You know those fridge magnets you casually slap onto your refrigerator? Those are about 100 times stronger than Earth's magnetic field. And when you compare that to industrial electromagnets or MRI machines, Earth's field barely registers. So if we want a planet-sized magnet strong enough to catch an asteroid, we're going to need something way bigger than what nature gave us. And that's where things start getting complicated. Let's talk materials. A small magnet works because of the way atoms inside it align their electrons, creating a magnetic field. But scaling that up to the size of a planet? We're talking about an absurd amount of magnetic material, far more than exists on Earth. We'd need oceans of iron, nickel, or even some exotic superconducting material that we haven't discovered yet. Even if we somehow found all that material, shaping it into a functional magnet the size of a planet would be a logistical nightmare. And then there's the energy problem. Magnets don't just work for free. If we're using a permanent magnet, it has a fixed field strength, and that's it. But if we're talking about an electromagnet, the kind of thing that can be turned on and off, we'd need insane amounts of electricity to power it. The kind of energy we'd need would make even our most powerful nuclear reactors look like disposable AA batteries. But okay, let's say we do somehow construct this monster of a magnet. Can it catch an asteroid? Well, no. Not unless that asteroid is made almost entirely of metal. And even then, it's not as simple as just flipping the switch and watching the asteroid veer off course. Most asteroids are a mix of rock, ice, and metals. Some, like those in the M-type category, contain enough iron and nickel to be considered metallic. But even these aren't like giant floating dumbbells in space. They're often mixed with silicates and other non-magnetic materials, making them only weakly responsive to a magnetic field. But let's assume we do find a nice, chunky, metal-rich asteroid on a collision course with Earth. Would our planet-sized magnet be able to yank it away? Unfortunately, even if the asteroid were fully made of iron, the answer is still a solid probably not. Here's why. Magnetic force gets weaker with distance. The farther away an object is, the less pull a magnet has on it. And space is huge. Even if our asteroid were a mere 1,000,000 kilometers away, which in space terms is like standing next to your neighbor's fence, our magnet would need to be absurdly strong to have any noticeable effect. The kind of field strength required would probably rip satellites out of orbit, mess with electrical grids, and maybe even pull the iron right out of our blood. Which, by the way, is another huge problem. A planet-sized magnet wouldn't just affect space. It would wreak havoc on Earth itself. The moment we turned it on, every credit card, hard drive, and electronic device would be fried instantly. Birds, which rely on Earth's magnetic field for navigation, would start flying in confused circles. And if the field were strong enough, it could even mess with Earth's own core, potentially disrupting our natural magnetic shield against solar radiation. So, in short, a planet-sized magnet is not only wildly impractical, it's also a disaster waiting to happen. Now, that doesn't mean we can't use magnets for asteroid defense at all. Scientists have actually considered much more realistic ideas, like using magnetic forces to manipulate metallic asteroids over long periods of time. Instead of trying to yank an asteroid away at the last second, We could use carefully placed electromagnets on spacecraft to subtly nudge an asteroid's course over years or even decades. Or, if we're feeling extra creative, we could try something even weirder, like painting an asteroid white. Yes, seriously. The Yarkovsky effect is a real thing. If you change an asteroid's surface so it absorbs and radiates heat differently, you can slowly alter its trajectory over time. But as cool as it would be to build a magnet the size of a planet, it's probably not the best way to save Earth. So, if an asteroid is coming, let's stick to the more practical solutions like nuclear explosions, gravitational tractors, or, not waiting until the last second to deal with a space rock hurtling toward us. If you enjoyed this wild thought experiment, don't forget to like, subscribe, and hit that notification bell so you don't miss the next deep dive into absurd science. Thanks for watching, and I'll see you next time.